All right, welcome everyone. The purpose of this video is to go over how to do empirical formulas given percent by mass data. So let's jump right in to question 1. I'm given this information about a molecule and asked to find its empirical formula. I know it's 65.5% carbon, 5.5% hydrogen, 29% oxygen, and all of these percentages are by mass. All right, so the way that I'm going to solve this problem is I'm going to work with a particular sample. That's going to be the easiest way to think about this. And specifically, the easiest size sample to work with is a 100-gram sample of my unknown molecule. Why? Well, because I have mass information and I need to find the relationship between carbon, hydrogen, and oxygen in terms of their moles. If I'm going to find the empirical formula, I need to find subscripts, and I know that subscripts are molar ratios. All right, so if I have a certain amount of grams of something, I should then be able to convert it into moles. So let's go ahead and try that. If I have a 100-gram sample in total and 65.5% is carbon, then 65.5 grams will be carbon. Awesome. And so now I'm just going to convert that into moles. I know that for every 1 mole of carbon, there's 12.01 grams of carbon. I got that from the periodic table. And so that gives me 65.5 divided by 12.01. 5.45 moles. And okay, 5.5% in a 100-gram sample would be 5.5 grams of hydrogen. The molar mass of hydrogen is 1.01 gram of hydrogen. 1 mole hydrogen. 5.5 divided by 1.01 gives me 5.45 moles of, let me be specific, carbon, hydrogen. Now finally of oxygen, and with oxygen I have 29 grams in a 100-gram sample of oxygen. Notice I don't need to deal with diatomic here because this is within a compound. That's something sometimes people get tripped up on. 16 grams of oxygen is the molar mass for every 1 mole of oxygen, and that's going to be equal to 1.81 moles of oxygen. All right, so now I have my molar ratios. The only problem is they don't look like nice, tidy subscripts, so I need to simplify a little bit. The way I simplify here is I just divide by the smallest number of moles. So divide all of these numbers by the smallest number of moles. 5.45 divided by 1.81 gives me 3. I'm going to round to the nearest whole number, 3 and 1. If my answer were close to 0.5, I would then write down 0.5 for that answer and then go back and double all of the subscripts. But in this case, all of my answers were very close to a whole number, and so I round to the closest whole number, and that is my empirical formula. And now, in order to find the molecular formula, well, I know that the molecular formula has a molar mass of 110 grams per mole. So I'm just going to compare that with the empirical formula that I have. I'm going to find the total molar mass of my empirical formula. So 3 carbons, 3 hydrogens, 1 oxygen. All right, and now let's throw this in my calculator. 3 plus 3.03 plus. And I get 55.06. All right, so I know that my empirical formula has a molar mass of 55.06. The actual molecule, how it actually exists, not in its simplified form, has a molar mass of 110 grams per mole, that means 110 divided by 55.06, let's just round to 55, gives me 2. And so that means that the molecule actually has double what the empirical formula has. So all I'm going to do is double all of my subscripts. So I end up with C6H6O2 as the molecular formula. All right, I hope that helped. Thanks for watching. Have a good day.